This is the final exam review. First, I'm going to be starting off with all of the functions and the things that I need to memorize. So exponential growth will always be PT equals POE exponent RT. PO being the initial value, the initial population, R being the rate or percentage, and T being time. We also need to know that ln gets rid of exponent. The equation for an ellipse is x minus h squared over a plus open parentheses y minus k close parentheses squared over b is all equal to 1. The equation for a circle is going to be x squared plus y squared equals 1, or open parentheses x minus a close parentheses squared plus open parentheses y minus b close parentheses squared equals radian squared. We need to know SOHCAHTOA. This basically is for always is going to be for a triangle. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. We also need to know that our A value will always be the adjacent, our B value will always be the opposite, and our C value will always be the hypotenuse. The identity formulas are as following: sine A cosine B plus or minus cosine A sine B equals sine open parentheses A plus or minus B close parentheses. The next one is cosine A cosine B plus or minus sine A sine B equals sine open parentheses A minus or plus B, so opposite operation to what we're doing. The next one is going to be 2 sine A cosine A equals sine 2A. Last one, cosine squared A minus sine squared A equals cosine 2A. Our table for our sine, cosine, tan, and radians is going to go as following. The pi is going to go from 0, pi over 6, pi over 4, pi over 3, pi over 2. Our radians or degrees are going to go from 0 to 30 to 45 to 60 and to 90. Sine is going to go from 0 to rad 1 over 2, rad 2 over 2, rad 3 over 2, rad 4 over 2. Cosine goes backwards, rad 4 over 2, rad 3 over 2, rad 2 over 2, rad 1 over 2, and 0. Tan is basically the quotient of sine and cosine, sine divided by cosine. Tangent will go from 0 to 1 over rad 3 to 1 to rad 3 to DNA. We need to know that sine, whenever sine or cosine is rad 4 over 2, that's always going to be equivalent to 1. We also must know all students take calculus, ASTC. I think I know how to figure that out. The arc formula is going to be SR radian. S being the circular arc. Oh, hold on. Yeah, so formula is going to be S equals R radians. We should know that a cubic is always going to look like a sine. It's going to go down. It's going to go up, down, and then up again. A square is always going to be a parabola, whether it's up or down depends on the last term. Our cofunction identities are tan open parentheses pi over 2 minus x close parentheses equals coterminal x, secant pi over 2 minus x equals cosecant x, and sine open parentheses pi over 2 plus h close parentheses is going to equal cosine h. We also must know cosecant is 1 over sine x. We must know that secant x is 1 over cosine x, and coterminal x is 1 over tan x. To get the midpoint, we need to find average of x's, so x plus 1 plus x plus 2 over 2, and average of y's, which is y plus 1 plus y plus 2 over 2. I'm gonna recap some of the important problems that I had here on my final exam. So question number 1 is let p of x equals x cubed plus 2x squared minus 9x minus 18. We want to use the factor theorem to show that x plus 2 is a factor of px. So factor theorem says that if x plus 2 is a factor, p minus 2 should be 0. So y minus 2. X plus 2 equals 0, so minus 2 minus 2, p equals negative 2 in order for it to be 0. We basically just want to plug in negative 2 wherever you see x, and then if your remainder is 0, then therefore it is a factor. To factor px completely, we must factor out the x and the 9. So from x cubed plus 2x squared minus 9x minus 18, we have x squared, open parentheses, open parentheses, x plus 2, close parentheses, and negative 9, open parentheses, x plus 2. We can factor out the x plus 2 since it's a common factor, following the analogy as following. 3a plus 5a is equivalent to 3 plus 5a. This leaves us to x squared minus 9 times x plus 2. We want to factor out, or just basically distribute, x squared minus 9 into x minus 3, x plus 3. And our final answer will be x minus 3, x plus 3, and then x plus 2 stays intact. So we have 3 answers. To find functions with population and exponential growth, we follow the population growth formula. When we want to figure out how many years, so t, we simplify numbers on both sides. We divide by a number next to e. Then we do ln of both sides. This gets rid of the exponent, and then we divide both sides by the percentage to get the final answer. And it should look something like t equals ln 25 over 18 all over 0.08, which is the percentage. When we do the rational zero theorem, we must take out the last constant. So this, in this case, x cubed plus 2x squared minus 5x minus 6. Our constant is going to be negative 6. We are going to factor it. Whatever equals to negative 6 when multiplied. This can be negative 1, positive 1, positive 1, negative 2, positive 3, negative 3, positive 6, negative 6, and then we just basically plug in. We plug in into all x values. If answer is 0, it is a factor. Display final. Yeah. When we want to factor completely, we just basically, it'll follow this format: x plus 3, x plus 1, x minus 2. But keep in mind that the first question, which is asking for all zeros, is going to be negative sign. So negative 3, comma, negative 1, 2. When it comes to an ellipse and we have an equation such as x squared plus 4x plus 4y squared minus 8y plus 4 equals 0, the first thing we want to do is accumulate all of the x values, all of the y values, and all of the constants on the right-hand side. We start off with the last or the second term. This is usually the one with the x or the y. What we have to do is we need to take the half of the second term. So if the second term was 4x, we take the half of that, which is 2, and then square. And this gives us our third term in our trinomial. So half of 4 is 2, and then square, that's 4. So our new equation thingy is going to be x squared plus 4x plus 4. We then try to factor into the perfect square. And if we have, per se, x plus 2 equals 0, this simplifies to x plus 2 squared equals 0. Yeah, we solve for both x and y. Keep in mind that an ellipse always needs to be equal to 1. That is the standard form. So always divide or whatever to get your answer to be 1 equals to 1. Also, if we have a coefficient and we have a third term inside, we need to multiply the third term by the coefficient and do it for the right hand side as well. When we graph an ellipse, the center is going to be the x and the y values, but negative operations to each side because we want to equivalent it to 0. Example being, if we have an ellipse of x plus 2 and y minus 1, our center is going to be negative 2, comma 1. We need to graph 4 points in an ellipse. Usually the 1 is the radius, so we need to move 1 unit up, 1 unit down, 1 unit left, 1 unit right. When we consider systems of nonlinear equations, we need to sub y into equation 1, but the first thing we need to do is okay, we have x squared plus y squared equals 1, and our second equation we have y minus x equals 1. We want to get the y value, so we follow or take out the easiest equation. This is y minus x equals 1. We solve for y. We have y equals 1 plus x. We want to sub in y into equation 1. We expand the square. We distribute. We simplify. We get rid of y. We factor 2x. We plug in x values into the first equation, which is y equals 1 plus x. So another example is 2x plus y equals 1, and we have y equals 4 minus x squared. We want to solve for y in either equation, preferably the one without the exponent. So we're going to be solving for y in 2x plus y equals 1. To solve for y, we must eliminate the 2x on both sides, so minus 2x minus 2x. Y equals 1 minus 2x. So our new equations are going to be y equals 1 minus 2x and y equals 4 minus x squared. We basically can just eliminate the y's. We are left with 1 minus 2x equals 4 minus x squared. The second step is to move everything to the left-hand side. So we subtract minus 4 plus x squared, and our new equation is going to be x squared minus 2x plus 1 minus 4 equals 0. We want to simplify this. We're left with x squared minus 2x minus 3. And we want to factor. When we factor, we get x equals 3 and x equals negative 1. Then we plug in into the first equation that we got, which is y equals 1 minus 2x. If x equals 3, we plug in the x's and we get negative 5 as the y value, so 3 comma negative 5. If x equals negative 1, we plug in as well and we get negative 1 comma 3. We need to take into consideration that a line will always follow the format y equals mx plus b, and a parabola will always follow the format the cubic, or the squared, I'm sorry. So we basically just start off by graphing the x and the y values that we got in the question above. And our parabola, because it was y equals 4 plus x squared, is just going to be 0 comma 4. So just following 4 on the fourth unit of the x-axis, of the y-axis, So another question says, evaluate and simplify sine, inverse of sine, radical 2 over 2 plus inverse of cosine, which is radical 2 over 2. We basically just want to set out the chart and add and just simplify. Evaluate the difference quotient. We have the numerator f, open parentheses 1 plus h, close parentheses, minus f, open parentheses 1, close parentheses, all over h, when f of x equals x squared plus 2x. For this, we must plug in the first value, which is 1 plus h, into both x squared and 2x. So this is going to give us 1h squared plus 2 times 1 plus h minus, and then we do f of 1. Basically, we just sub in 1 into the x values as well. This is going to be 1 squared plus 2 times 1, all over h. We want to acknowledge that 1 plus h squared is the same thing as 1 plus h, 1 plus h. which is going to, if we distribute correctly, it's going to be 1 plus 2h plus h squared. Then we distribute 2 amongst the 1 and the h. We're going to have 2 plus 2h minus 3. We simplify, and our final answer is going to be h squared plus 4h. We see an h in common, so we can just eliminate h, and we are going to have the answer of h plus 4. To find the average rate of change is just y2 minus y1 over x2 minus x1. Find 2a, Find 2 degree plus cosine degree if tan degree equals 3 over 4 and degree is in quadrant 3. We want to acknowledge the tan. The tan is going to be TOA, so opposite over adjacent. We're given tan, so we automatically know that our adjacent is going to be 4 and our opposite is going to be 3. In order to get hypotenuse, we must do a squared plus b squared equals c squared. We have 3 squared plus 4 squared equals c squared, and if we simplify further enough, we are going to have radical 25 or 5, so hypotenuse is 5. Since we are trying to find sine 2 degree plus cosine degree, we are going to use the identity formulas. 2 sine a cosine a equals sine 2a. So sine 2a, right, plus cosine degree, which is what we're given in the problem. We want to do the sine of this triangle. Sine is opposite over hypotenuse, so negative 3 over 5. Cosine is going to be adjacent over hypotenuse, so negative 4 over 5. We have 2 sine a cosine a, which is going to translate to 2 times negative 3 over 5 cosine times negative 4 over 5. If we multiply 3 over 5 times 4 over 5, we're going to be left with 12 over 25. Since we need to subtract cosine as said in the problem, I know it says addition, but the problem says that you need to change operations. We're going to subtract 4 over 5, which is going to give us 4 over 25. That's the final answer. We want to evaluate and simplify cosecant sine inverse 1 over 2 plus cosine inverse 1 over 2. The first thing we need to do is draw the little table and figure out that sine 1 over 2 is equivalent to pi over 6 and cosine 1 over 2 is equivalent to pi over 3. This expression becomes cosecant pi over 6 plus pi over 3. If we simplify, cosecant times pi over 2, and according to the formulas, we know that cosecant equals 1 over sine x. So this will give us... Okay, so since the sine is pi over 2, we must know that the sine of pi over 2 is 1, because it's rad over 2, but rad over 2 is actually 1, so 1 over 1, the answer is 1. We want to evaluate the difference quotient, numerator, f, open parentheses, pi over 2 plus h, close parentheses, minus f, open parentheses, pi over 2, close parentheses, over h, when f of x is sine x. We first want to plug in the function. We want to plug in wherever we see f, we want to plug in sine. This leaves us with sine, open parentheses, pi over 2 plus h, close parentheses, minus sine, open parentheses, pi over 2, close parentheses, all over h. We use identities to figure out that sine pi over 2 plus h is equivalent to cosine h. We use another cosine. No, what am I saying? Our final answer is going to be cosine h minus 1 over h. Suppose that f of x is a linear function. If f of 1 equals 0 and f of 2 equals 3, find equation defining f of x. Basically what we need to do is we need to know that the formula for this is m equals f over 2 minus f over 1 over 2 minus 1. So 3 minus 0 over 1, 3. So using the point 1 comma 0, we need to use this following formula. F of x equals m open parentheses, x minus x1, close parentheses, plus y1. We basically plug in the values and we get 3x minus 3. For solving trigonometric equation, 4 sine degree plus 3 radical 3 equals radical 3 for all values degree on interval 0 is less than or greater than degree, and then the other sign 2 pi. We need to do 4 sine degree plus 3 radical 3 equals radical 3. We must subtract radical 3 from both sides to isolate the sign. We do minus 3 radical 3 minus 3 radical 3 on both sides. Imagine on the right hand side, radical 3 has a little exponent, a little coefficient of 1. This gives us 4 sine degree equals negative 2 radical 3. We want to isolate sine, so we must divide by 4 on each side. We are left with sine equals 1/2 times radical 3 over 2. If we simplify this further, we get sine equals negative radical 3 over 2. So radical 3 over 2 sine is at pi over 3 and 2 pi over 3. How is it at 2 pi over 3? Because pi minus pi over 3 equals 2 pi over 3. We want sine negative. Sine negative is in quadrants 3 and 4. This means that pi plus pi over 3 equals 4 pi over 3, and 2 pi minus pi over 3 is 5 pi over 3. So our final answers are going to be 4 pi over 3 and 5 pi over 3.